Welcome to the ZKTeco's training class. Today we are going to talk about anti-passback, interlock, multi-lock access concepts in ZKTeco systems. The following is all the content covered in this training. In the first part, what is anti-passback? Anti-passback is a security feature that prevents a credential from being used consecutively to access an area without first exiting it. There are two main purposes. The first is to ensure that credentials, for example, cards, biometrics, are not reused for unauthorized access, for example, tailgating. The second point is enforces accountability for entry and exit. So how to complete the anti-passback? First, when a user enters an area, their credentials are marked as already in the area. Second, the system denies them re-entry until they leave the area, and their credentials are marked as already outside the area. Third, it can be used with indoor and outdoor access points. Specifically, when a cardholder enters an area, if card readers are installed at both the entrances and exits of the area, the cardholder cannot use the same card to enter the area again at the same time. This avoids the situation where one person enters and hands the card to another person for use. For example, we can see in the figure that when person A lends the card to person B after successful verification, A can enter the room without the card, and B cannot enter the room with the card. Common application places for anti-passback include high security areas, places with extremely high security requirements, such as bank vaults, laboratories, data centers, classified units, military bases, etc. Prevent tailgating entry and credential sharing behavior occurring. Parking lot, prevent vehicles from entering again without driving out. Industrial facilities premises, ensure workers follow safety procedures. The second part introduces interlock. Interlock or man-trap is a sequential passage mechanism in which two or more doors are interconnected so that one door cannot be opened until the other door closes. From the picture below, we can see that when the first door is not closed, people cannot enter the second door. The purpose of interlock is to control access to highly sensitive areas by ensuring that only one person or group of people enters or leaves at a time, or lock. There are three main characteristics. The first is electronic door interlinking, which can realize sequence control, physical isolation, automated management functions. The second is to perform biometric identification or access card verification on every door, thereby realizing the functions of multi-biometric verification, permission tiering, anti-fraud technology. The last point is alarm triggers for force entry or simultaneous door opening, such as force entry alarm, simultaneous door opening alarm, inbox alarm, integrated incident response service. Its application scenarios mainly include clean rooms in laboratories, sensitive data centers, bank vaults, or other areas with high security levels. Through the previous introduction, I believe you have a certain understanding of anti-passback and interlock. Now let's understand the difference between anti-passback and interlock. In terms of focus, anti-passback is to track the user's entry and exit situation in order to clarify the responsibility. Interlock is controlling simultaneous access to an area. In mechanism, anti-passback prohibits re-entry without leaving first. Interlocking prevents multi-doors from opening at the same time. In terms of applications, anti-passback prevents access control, credential sharing, or trailing entry, while interlocking ensures access to sensitive areas in order. In terms of hardware requirements, anti-passback requires card reader terminal equipment with entrances and exits, and interlocking requires interconnected doors and sensors. The third concept we want to put into is multi-lock. Multi-lock is an advanced version of interlock. It collaborates with multi-doors through a central controller and realizes dynamic rights control based on preset rules. Its core goal is to improve the security, traffic efficiency, and management refinement level of complex places, such as industrial areas, laboratories, and high-security facilities through multi-door linkage, group-based authority allocation, and flexible conditional logic. Similarly, multi-lock has three main characteristics. The first feature is that the multi-lock system uniformly manages and controls multi-doors through a central controller. The controller will simultaneously send instructions to the electric locks of multi-doors according to preset rules and permissions to realize the simultaneous opening or closing of multi-doors. The second main feature is group access control. The system will define and authorize different user groups. When a user authenticates, the access control system identifies the group to which the user belongs and determines whether to allow him to pass through a specific door based on group permissions. The third point is conditional logic. Multi-lock allows specific doors to be unlocked based on preset rules, which can be based on multiple conditions such as time, date, person identity, door status, etc. The multi-lock system is a combination of the above three characteristics. It is mostly used in industrial areas with multiple restricted areas, high-security facilities with team-based work processes, clean rooms, or multi-compartment airlocks in laboratories. After introducing multi-lock, we will now talk about the concepts of time zone and access level. Time zone settings are functions that the access controller and control panel can only restrict user access for a specified time. Then the time zone can be set to weekdays, weekends, holidays, etc. As shown in the figure, the time zone where employees can enter the office is from 9 o'clock to 17 o'clock. When employees want to enter the office at 15:20, they will not pass by swiping their cards because it is not within the allowable authority range. However, when employees swipe their cards to enter the office at 9:05, success can be recognized because it is within the authority time zone. Access level refers to the structured classification of user permissions in an access control system, typically including accessible physical areas, for example, office zones, server rooms, warehouses. Permitted time periods integrated with the time zone feature, such as restricted to working hours. Authentication methods, for example, card swiping, passwords, biometric verification. Permission priorities or constraints, for example, temporary access, emergency override permissions. In summary, access control is equal to where plus when plus what. So what role do time zones and access levels play in access control? There are two main points. The first point provides granular control over user access. The second prevents unauthorized access outside defined times or roles. As shown in the figure. In Figure 1, the time zone where the engineer can enter the office is from 12 o'clock to 15 o'clock. When the engineer wants to swipe his card to enter the office at 16 o'clock, the system will reject it. Figure 2 shows that the time when engineers can enter the warehouse is from 16 o'clock to 18 o'clock. When engineers swipe their cards to enter at 17:10, it is allowed. Figure 3 shows that engineers can enter the material management area at any time. This picture completely shows the application of time zone and access level in the access control system. On this page, we are going to talk about how to use time zones and access rights levels to improve anti-passback, interlock, and multi-lock functions. The first is time zone integration. Limit anti-passback, anti-tailgating, or interlocking functions to specific periods of time, for example, during business hours. Ensure that the door remains locked during non-working hours. The second is access level integration. The multi-lock system defines which users or user groups can enter specific areas. Only authorized personnel are allowed to enter sensitive areas. The third is to enhance security. Combine user accountability mechanisms, anti-passback, anti-tailgating, controlled order of traffic interlocking, and group-based access rights multi-locks with time-based and role-based restrictions. Returning to ZKTeco, we will implement the corresponding advanced features in the following ways. For example, anti-passback can be implemented on edge devices such as controllers, standalone terminals, or entry gates. Interlock can be configured on ZKTeco's equipment to use flexible logic to synchronize the operation of multi-doors. In terms of multi-locks, advanced hardware supports complex interlock control for multi-doors and multi-users. In addition, ZKTeco can also implement integrated functions and edge device functions. Because ZKTeco's system allows controllers, terminals, and gates to work seamlessly together to form a comprehensive access control solution. The functions of edge devices are mainly reflected in features are built into firmware, reducing reliance on external software. Supports standalone operation and can also be integrated into larger access control systems. Finally, let's summarize the key points of the whole section. Anti-passback ensures the implementation of user responsibilities by preventing the abuse of credentials. Interlock control controls the order of people entering high-security areas. Multi-locks provide advanced control methods for complex access scenarios. Time zones and access levels enhance system flexibility by defining when and where users can access. So why ZKTeco? Because ZKTeco's advanced systems provide edge-level functions with seamless integration, they create a scalable and powerful security solution to meet the needs of modern access control. That is all the content of this training course. I hope you will gain something. If you have any questions, please leave a message in the comment area. Thank you for watching.